Probability using Venn diagrams. We can use Venn diagrams to work out probabilities. Let's have a look at an example. In this Venn diagram, we have the numbers of students in a school. This symbol is the notation for the universal set. The S simply stands for students that can swim, and the L stands for the students that are left-handed. There are 21 students who are both left-handed and they swim. There are 136 students in this section of the circle, which means that 136 students swim, but they're not left-handed. If we wanted to know how many students swam, regardless of whether they're left-handed or right-handed, we would add these two together. Similarly, in this section of the circle, there are 8 students, which means that 8 students of the left-handed students don't swim. However, in the school, the total number of left-handed students, regardless of whether they can swim or not, is 8 plus this 21. And these students outside the circle are those students that are neither left-handed nor can they swim. Therefore, they are right-handed non-swimmers. Now, for this sort of Venn diagram, the questions could be asked as follows. Now, the first part of the question is asking for the probability of L with this funny N, S. Now, what does that mean? The symbol here in the middle means intersection of the two sets. So, this refers to this intersection, the overlap. So it means the students that are left-handed and swim. So that is 21 out of, if you add up all the students, that gives us a total of 205. So it's 21 over 205. And the next part of the question is the probability of L with this U symbol S. Now, what does that mean? This symbol in the middle, which looks like a U, means union of the two sets. And that is the probability that the students are in at least one of these two sets. So they can be in either that or that at least. So that would be all the students within this region here. So it's 136 plus 21 plus 8. Because all these students are at least swimmers or left-handed, or of course both. So my answer is 165 out of 205 students altogether. In the final part of the question, we have the probability of L, remember this means intersection of S, and this little funny dash. Now this dash actually means the complement. Now the complement means the probability that the students are not in the intersection of L and S. So that means this section is not what we want. So this is the complement. So we don't want this section. Therefore, it's all of these students, all of these students, and all of these students, because none of these students are in the intersection. Therefore, that adds up to 184 over 205. Now, in this example, we've been given some information and we have to fill in the Venn diagram. So Paula is organising a day out for her family. She's organised ice skating and biking. We know that 20 family members are coming. Of those, 16 would like to do at least one activity. 10 want to ice skate and 3 would like to do both. So if 16 would like to do at least one activity, then there are 4 people who don't want to do anything, so those 4 will go in the outside of the circles. There are 3 people who'd like to do both, so they will go in the intersection. Then if 10 people want to ice skate, and 3 of the 10 ice skaters are already here in this intersection, that means there must be 7 remaining in the other part of the circle. And therefore, if we add up these 3 numbers, that will give us 14. So we know that there must be 6 left in this section of the people who just want a bike. Now that we fill in our Venn diagram, let's have a look at some of the questions. So the first one is we have to find the probability of I intersection B, which is simply these 3 out of a total of 20. So the probability is 3/20. The next one is the probability of the union of ice skating and biking. So they're doing at least one of those activities. So that will give me 7 plus 3 plus 6. And that's 16/20. Now the last one is the probability of the complement of I. That means those that are not in I, and the union of B. Now these ones are sometimes a bit tricky, so be careful. So if we look at the diagram, we have these 10 people who are ice skating, so we don't want those 10 people ice skating. However, 3 of them are biking, so they'll be included in the B part of it. So it's only these 7 that are excluded. So these 4 and these 6 are in the complement of I, but these 3 are in B, so this is the union. Therefore, it's 3 plus 6 plus 4 over 20, which is 13/20. Now here's a different one. In this we're going to use a bit of algebra. So a teacher is organising a school trip to Paris for the students in Year 7. There are 120 students in the school year. 72 students study history, 90 students are visiting Paris, and 12 students don't study history and aren't visiting Paris. What we have to do is find the probability that a student is studying history and visiting Paris. So first thing we're going to do is fill in the Venn diagram. Now we know that there are 72 students in this circle and 90 in this circle, but what we don't know is what is in the overlap. So we can't subtract this amount in the overlap from 72 in the whole circle to find what's in this section. And similarly, we can't subtract whatever number is in this intersection from 90, which is in the full circle, to find out what's in this part of the circle. So what we can do is we can let this number be called X. But before we do that, we do know that there are 12 students who don't study history and aren't going on the Paris trip. So what we'll do is we will put those 12 in there first of all. And then we've got our X in the intersection because we don't know what it is. So we'll call it our unknown value of X. So then this part of the circle will just simply be 72 minus X. And this will be 90 minus X. Now, because we know that there are 120 students altogether, we know that these students plus these students plus these students plus these 12 students equal 120. So let's write that down. So the first part, then the X, 90 minus X, and then the 12. So that equals 120. And you can see now we have a simple linear algebra equation to solve. To answer the question, what is the probability that a student is studying history and visiting Paris, i.e. the intersection, which is this part here? We have 54 over 120. Now it's your turn to answer some questions. Pause the video and have a go. How did you do? Here are the answers. If you answered any incorrectly, have a look back through the video and then try again.